everyone to this kernel CI session. My name is Emilio Casagrande. I'm software engineer in the Lava team. Tyler is working with me on kernel CI. So how many of you already know the system, apart from the familiar faces? Yeah. All right. So I'm going to go through a quick overview, background of the system, where we started, like a really high-level overview of how the system is made up. If we have a little bit of time, we go through the website and see how it works, and then we'll have questions and open discussions. We actually want to have more time for discussions, because in the last few months we didn't really progress on kernel CI for over reasons. So I think you're all familiar with the automation problems. When you have a repetitive task, you start working on something to automate it, you have another job because you lose time and you don't work anymore on your original problem. So that's where we enter here, and we wanted to help the kernel developers, removing the burden on the automating the boring stuff and helping them doing that, basically. So our goals were to build every configuration, every kernel configuration for each architectures, architectures where we were interested, boot those results, run tests on them, repeat this for each kernel change, not each kernel commit actually, but each kernel change is based merge, yeah, exactly. And then, yeah, repeat this every time, and report the results in a sensible and useful way, and actually try to make a profit out of it. So why we started this? There was something out there. There's a few systems that try to do that. They're not open source. All the kernel developers had like their own scripts, their own way of doing things, and not really sharing the results in a really open way. So we want also to provide like a website, a platform for the community, where you can go check the results and be sure that we are testing your code. And yeah, obviously, we wanted to make sure that all the work is bug-free as much as possible and regression-free, at least from an upstream point of view. So yeah, before going into detail of the system, a glossary of the terms that we use on kernel CI that might not be that clear. We have three main sessions. Well, one is a job, one is a build, and then we have a boot. So a job for us is the bay unit where everything starts. It's more or less what you have on a Jenkins job kind of thing. So it's made up of a tree and a kernel. The tree is a name Git repository, whatever name you want to put to your Git repository. The kernel is actually a value that is computed from the output of a git describe command. So it takes into account the kernel version and the SHA of the latest commit that you have.
So an example of a tree name might be mainline, Linux next, net next. So it's typically the same name as the maintainer's tree, what they've named it.
Yeah. And that's the base unit where we start the job of compiling and testing. After that, we have a build, but it's actually a job plus the dev config, and that says like all the multiple dev config configuration we test. And it outputs some artifacts, usually the kernel image, what we use to boot. All these are still available on the system, the artifacts as well, so you can try to reproduce what you are doing. And then the last one is the boot, but it's a special case of test if we actually try to boot what we build. And yeah, that's just a test, and we measure the results of that.
Sorry.
Yeah. Yeah, sure.
The bullet. What does base unit mean?
It's for us is where everything starts. It's just like the entry point for our system. So it's really the Git repository. That's what we need.
Okay.
But yeah. If we don't have that, we don't have anything else that comes after. So yeah, what is kernel CI today? It's running on one server. We have 8 builders. Probably it's outdated. This is from February. I think we have probably something more, but I don't know if it's
we still have 8
builders. Okay. I guess we still have 10 distributed hardware labs, but we're doing the boot testing. 160 unique boards, probably there's something more, new boards have come in, but 500 builds is probably wrong, it's probably 800,000, and yeah, we're more than 2 million boot reports with kind of 500 boots per day, more or less.
And so just to go back and point out something, so in the beginning, there's a lot of kernel maintainers that were actually doing this work, but they were doing it for the boards they cared about. So the whole idea of the project is to try to aggregate those results into a common interface so that everybody can view those results rather than trying to figure out where those results are and whose server. So that's kind of the idea here, is that we've built this up so that we can work together with other people's labs and their automation scripts so that we can bring those results together in one place.
So yeah, this is like really high level overview of the system. On the left-hand side, we have the labs, but actually the boot labs, our builders, and the kernel trees. The kernel trees is it's a manual setup. We start them up basically. You tell us which is your tree, and we start monitoring the tree. At each merge request, they trigger a build. The builder interacts with our API. They just send the results there. They upload all the artifacts. And then from our API, we just like trigger the boot process from the overlaps. The dashboard is it's an implementation, a visual implementation of our API, so we can throw it away. Somebody else can do whatever they, on our dashboard if they want.
So a good example, that's the Bay Libre guys.
Yeah.
They built powerci.org, which is the same system, it sits on top of kernel CI, but they added power measurement to it for all their boards. So they threw a custom front end essentially on top of the API server that we built.
They're using the same API. When we have reports, but if you're subscribed to kernel mailing list, you probably saw them. And yeah, and that's a really high level overview of everything. Yeah, this was the road ahead in February. It completely derailed because there's nothing there, but it's actually being done for other things that we had to do. Yeah, that's really quick introduction of the system. If you want, we can go through a little bit of the UI if you don't know it, or if you have questions on the UI, or we can just like go directly to open discussion if you have something else.
I got a question for the group here. Who's running the latest released mainline kernel on their laptop right now? Show of hands. 1, 2. And what's the reason for not doing that? Just curious. Is there a good reason, or is it just you're taking the distro kernel? Distro kernel? Okay.
So yeah, well, if you have a little bit of time, we go through a website. So, but we need help. We especially need help in going through our results and making sure they are correct, and making sure that what we report was not working is actually really not working. So yeah, confirm the issues. We report, send us bugs if you find something that is not working, send patches to the kernel, send patches to us if you have new boards that you need support to, or whatever else you need. There's all the address open there. We are on IRC, so just reach out to us.
Yeah, and I think what we need to hear is that we've got so many different types of boards now that it's, you know, Kevin and I, Milo and Mark Brown are overloaded trying to fix the boot issues that come up. So Ard has been doing a really good job getting rid of the build failures. So I think we're covered there. But the boot failures, if you have a particular platform you're interested in, please try to monitor the results. And if something fails, it gives you the bisection points. And if you can, if you have the hardware available, please try to bisect and report on the mailing list. That would really help us out. Because right now it's, you know, essentially 2 or 3 people doing that. And, you know, depending on the day, Linux Next breaks in very magnificent ways. So it's always nice to have a little bit of extra help.
Can you show a little bit of the system?
Yes, Alan.
How do you go full screen here?
I think it's just going to view stuff here.
Oh,
It's
okay.
just full screen. I don't know how to get out of full screen. I don't know if I have a full screen.
F11, but you don't have F11.
Where's F11 on?
Yeah, exactly. All right.
You guys have time for a question?
Yeah, sure. Go ahead.
You're running out there.
So You indicated that if we send a kernel tree in, we can run a kernel tree in through the kernel CI, right? You guys will monitor our repos and branches.
Yeah,
So,
we can
okay,
do
so I did actually do that. Sent you an email on it, but I haven't seen anything come out of it. I mean, this is for TI, so we're.
Oh, that's because you had custom dev configs in there.
that. Yeah,
No, we don't use custom, we use the base def configs, but we use config fragments to modify for our board so we can
I
boot
think that's the thing,
properly.
is those are out of tree, right? The config fragments. We merged
Currently.
it. Yeah, see, I think that's
Yeah.
just gonna take a little bit of work to do.
But we
that.
do use merge config. I mean, we do have a certain process. I didn't get any feedback, so I didn't know where it was going. We're trying to submit that tree, but I mean, these are patches we need to be able to test things.
Yeah, we can work on that, like,
Yeah.
I do remember that email thread now. I think it
Yeah.
got stopped as we got pulled off the project. So there's really nobody there to, this is kind of in our free time type thing.
Okay, yeah,
if you
'cause I
still have
stopped-
if you still have the email thread, just bring it up again so we can.
Okay, because
remember
I stopped updating the tree because it was kind of, I didn't get anything back. But
Okay, no, no.
we tried to submit that in through, because I think you have a lot of TI boards that we can test against too, so.
Yeah, yeah.
I mean, those config fragment ideas are, we're gonna try and RFC it upstream to see what we get for feedback. Maybe talk to Tony a little bit.
Yeah, just bring up the discussion again so we don't forget.
Other questions?
Yeah, because we gotta have to modify the scripts to go and know what config fragments are out of tree so that we can run merge config to create those fragments. More or less like what we did with the LSK. Yeah, go ahead.
We do use the merge config, but we created a script around merge config to actually combine all of those config fragments and amend them to multi v7. Okay, so we put a script around it, merge config, that says, take these, and a map file that says, take these config fragments and amend them to the target def config, and that should boot specific boards.
So are you planning to upstream the wrapper around merge config?
Yes.
Is that, okay, that's the case.
We're gonna RFC it and see what we get back from it. I mean, I think U-Boot Tom Reaney's interested in the same concept as well.
Yeah.
And again, I wanna socialize it first before I go and push it.
Yes.
Yeah, I mean, it's all open source. All the scripts are open. So they're all in GitHub under /kernel CI, and I could point you to where you need to make the changes, and then just do a pull request and we'll merge it.
So I don't know if this is good time, but since you have the GUI open, I'm using this same GUI almost every day to check for regressions, usually after RC2. But I'm having a hard time. I would like to have a static link for, if you look at the top line where it says for next and then latest boot status, the pink one showing the failures. So if you click on that one, so I would like to have like a symlink that's a static URL to see this on daily basis. Right now it's dynamically generated link, so you have to click through it to go to it.
So you mean like clicking the latest one?
Yeah, today's
yeah,
the most recent next. It's just, I guess it would be just adding a
So
symlink
yeah,
on the
I'm
web
not
server.
able to exit full screen here, but if you go next to this URL /latest, you will get to the latest boot report.
Oh, you have such a link?
Yeah, we have. It's probably one of the
yeah,
last thing.
I mentioned it to Kevin like 6 months ago, so it sounds like
It's
you've
actually one of the last thing I did before
Okay,
stopping
cool.
working on this, but
So-
it's available. So we never announced it, but it's actually available.
So what is it again?
Yeah, so it's like kernel CI /boot /net next /latest.
Next latest, okay. Yeah, thanks.
Yeah, I'll show you if I'm able to exit full screen from this computer.
So what I've been
How does it work on the control? No,
It's not running
it's
Chrome OS.
Ubuntu. There's Ubuntu. So I don't know. Sorry. Yeah.
So if you alt tab, you can close the browser and start back up.
Nope. Yeah.
There's layers of hacks on this laptop.
Yeah, we are. Right.
There we go. So let's go into this. So it'd be next latest, like this?
Yeah. Not job, boot, build. No,
Build?
Yeah, build. Or boot, if you want.
Like that? Or no,
Remove
here?
job, yeah. It's working?
Yeah, let's go build. Net next. And then slash latest here.
No, it should be built. Try with the boot, because a boot should work.
Net,
Yeah, already.
next. Oops. Latest.
Yeah, slash.
404. Yeah, that's good. Okay, we'll take that down as a note to look.
It should work.
Okay, what else do we want to show on the UI? I can try this.
Yeah. Let's go through. Let's just go through from the jobs and everything.
All job? Oh, maybe that's the URL.
Oh, yeah. Yeah, you're right. You're right, because we're bored.
So boot. Yeah, go ahead.
Yeah, sure.
Okay, so this seems to be a tool where the audience is SOC maintainers. Because you're checking as patches are flowing upstream, you're making sure that you haven't broken this vast array of boards, which is pretty cool. So I'm really interested in the part where someone reacts to the bug. So is that formalized at all? I know you send reports to lists, and Arndt does a lot of work fixing stuff. Yep. But I guess my question is, how do you envision this scaling out to other audiences? Or, I mean, you mentioned the Power CI, so I'm kind of interested in how they're doing it, or, I mean, what other types of tests do you envision doing?
So right now, we're going to focus on boot testing because we don't have the resources to do anything else. Now, if we start getting more community involvement and people are helping report bugs upstream that they find on kernel CI, and that takes less load off of us, that'll free us up to start running the tests. But the problem is, if we add tests now, that we just doubled our workload, which we already don't have enough time to do. So we're kind of staying out of that realm. Now, if you go look at the code, there's Hackbench, LTP. We have all the stuff integrated, ready to run. It's just the amount of failures that that's going to produce aren't going to be sorted out by just us three. So we need to get more community involvement before we start doing it. So if you guys find a bug on kernel CI, use the reported by tag when you send a patch to the mailing list, because that helps us track people. Oh, go ahead, Tony.
Sorry to ask a question again, maybe this is fixed, but for reporting bugs, what would be helpful would be always to see the latest known boot. Right now it takes quite a bit of point and clicking to find out when it actually broke.
So you're not looking at the emails that we sent out then, because we've just added this.
Oh, you added that one, okay.
It tells you
Thanks.
when this regression was introduced,
Right.
how long it's been there.
Okay, cool, great.
If you look at our mailing list on kernel build reports, I mean,
Yeah, that's why I never used the emails before, because I couldn't figure that out. But if I'll start using them then. Thanks.
What about LTSs? Have you guys have any plans on testing the actual LTS itself?
so we do stable, right? We test the stable tree and we test the RC. So when Greg Hartman sets his patches out, we actually test those and check them for regressions and send the email directly to Greg Hartman during his stable RC review. Yeah, so eventually those become LTSs.
So you
right?
test RCs?
Yeah, absolutely, and stable. So once we check the patches in flight before they're applied and the stable bridge after they're,
So is that something that's been very recent?
probably the last 6 months.
Okay, because there must have been something broke in the he broke something in the last build break on the last one. I mean, Arn fixed it again, but I mean.
Yeah. So that was all, I mean, Art was referencing Mark Brown's build bot, but our build bot was showing the same problem as well. It's just one of those things like, we can report it, but if nobody's looking at it right now, we've been pulled off the project. So it's kind of, this is where we need the involvement, people watching the results.
Unrelated to my last question. So do you guys have a sense for how many of the failures that you see are actually because of a kernel regression versus something that's gone wrong in the board farm?
So the biggest issues we have with infrastructure failures are we add a whole pile of things into a dev config and we no longer can load it at that particular memory address, right? So we get a lot of those failures. I'd say that's 10 to 20% of the failures, we get something like that. Typically our infrastructure is pretty good on the running it on the hardware. We've spent a lot of time before we actually went public with this, working through all the automation scripts, trying to make it as robust as possible. The other thing that kills us is QEMU, because somebody will put a patch in and then QEMU lags behind and then it'll be broken for a while and we'll bisect it and then we'll have to go find somebody and say, oh yeah, no, you need to use QEMU 2.7 that's not released yet so that the kernel's boot. So we have a lot of problems with QEMU in that sense.
Is that QEMU bugs then, or?
Well, it's like somebody enables a feature in the kernel which breaks QEMU, but the QEMU developers know about it, so they patch it. But then the next release cycle, before that QEMU version gets in Debian, where we can pull it, even in testing, right, lags behind. So there's like right now, I think we have an issue with AR64 QEMU. It's completely broken because we need to upgrade to 2.7. Well, it's still in release candidate. So, is it packaged to Debian testing yet? Okay.
Because the QEMU master is relatively stable as something to build from, especially when you're building the release candidates and the tag builds.
Yeah, I guess we could. I prefer if we could get it quicker, but you know, in these situations, I think that would probably be a good start.
Yeah, the trouble is you've got a lag for the distributions, and then
Right, but you've also got to convince everyone who's running a lab to take this probably safe.
And then, you know, I'm sure you guys test all the different configurations of QEMU, where you try to at least, right? But then,
Yeah.
you know, if we go to master and then it's breaking something else, you know, we
yeah,
kinda,
yeah. I mean, master's probably a little flippant. I run master all the time, obviously, but yeah, keeping up with the releases because we do a new release every 3 months. So.
So I guess the question is, how many times does QEMU find an actual kernel bug?
I'd say, so QEMU itself, I found 5
Okay.
actual kernel bugs. I think we have over 115 that we've reported upstream and fixed.
Oh, okay.
Verified it, but that
Yeah, I was gonna ask in general about your bug metrics. That's actually really good to be
I think
tracking.
the neat part is I don't know if there's anybody doing KVM testing the way we are. So we actually boot ARC64 target and ARM32's targets, and then launch a KVM guest with the upstream kernel on both host and guest. And we found 2 issues there that actually broke ARM and ARM64 KVM support. So, you know, I think that level of testing is really good, and those are kind of complex use cases to be testing continuously, and we'd be unable to do that. Mainly, I would say it's mostly device tree changes that break things from time to time. We found some pretty nasty memory management ones. I think we probably got 15 memory management things that like broke LPAE on ARM and things like that. So we are finding some really good bugs, but those ones usually take a little bit more analysis than we have time for, unfortunately. Any other questions? These are good questions. It's a good discussion.
So funnily enough, we have similar problems with tracking all the random testing that gets done on QEMU and seeing when things break. So we're quite interested in seeing whether or not we can use kernel CI as a dashboard on the QEMU build status. But how much time do you spend keeping the web front end up and running? I mean,
Right,
So is
right
it a
now,
se-
0. Right now, 0.
3 months
It's,
hands-off,
yeah.
no one has touched it.
okay, so once you get it, invest the time in getting it set up and then it can just sit there running without
For now, yes.
without being handheld. Okay.
So I did make a change yesterday, I added a nearby tree.
Yeah.
We add trees to it because it's easy, it's a simple config change. But, you know, as far as redeploying the services, we haven't done that.
Yeah, there's probably more interaction with other people in the community, let's say, but yeah, that's like board enablement and like fixed configuration for the boards, but on the website, there's nothing happening basically. Apart from new features that we have to develop, but yeah, we need more resources.
So architecturally, is the data all in one place? I mean, is there like a single server that has the data from all the board farms, all the boards? Okay.
The artifacts, it's just one server, it runs everything, but that's a business driver. there. The API and the artifacts are there as well. We keep them only for 45 days. So, yeah.
So what we'd like to do, we have a proposal for kernel CI v2, which essentially is, I don't know if you guys saw the keynote on Monday morning, but I demoed this thing called getci.com, which is a scalable microservice architecture for doing continuous integration. And it more or less borrows from the concepts that we wanted to do with kernel CI v2. So our hope is if we get a little bit more time, we could build something where it's, microservices to do all of this continuous integration for the kernel. And I think it'll scale up a lot easier. We'll have more replication, load balancing, persistent storage, redundant database, all the things that you should have in a cloud service that, when we were building this, we didn't envision it being a cloud service. We just wanted it, the results in one place, and then it turned into that. So we would like to re-architect it slightly and have it a little bit more scalable. I think the neat part about kernel CI right now is that I've been working on Lava for 3.5 years, and I think this is the largest deployment of Lava that we've ever seen. I mean, there's 10 labs. There's 11 labs, one of which doesn't, Kevin, he switches back and forth whether he uses Lava or his own scripts, but there's 10 labs that are using Lava now. Lava 1 right now, so that's the other part of the kernel CI v2 is Lava v2 offers a lot of really good features, and there's a lot of optimizations, and we can do testing faster with v2, but it's quite a churn to move to it as far as getting all the boards supported. And we were just talking about this today. So with the V1 job templates, the way we template the things, it's fairly generic for each board. Whereas within V2, there's a lot more flexibility in what you can do with the boards, which is great, but now they're all encoded in the job file, so they're less generic jobs. So we were trying to think through how we do a template, like use a templating engine like Jinja to be able to dynamically create jobs for, the boot jobs for all these boards that are supported in V2. So that work needs to happen. That needs to happen regardless for CI Linaro in general to be able to do that, but then hopefully we'll be able to leverage it for kernel CI and make that manageable. So the idea would be there's a base template for doing a boot on an ARM board, and then you have an inheritance for a specific device that maybe needs a few extra options in there, right? And so you'd have something that's layered, that's easier to change. That way you don't have to change gigantic templates all at the same time.
So in terms of workflow, when you detect something's broken in the build, is it only when it's gone into Linux Next or into a maintainer subtree that you're monitoring? You're not doing anything specific like monitoring patches as they go onto the mailing list?
No, not like Zero Day does, no.
Right,
and it's really because we have eight builders. Zero Day has got just a massive amount of hardware, that they're able to do that with. So, it would be nice to be able to do that, but I think they're doing a great job with that. And, they're offering a lot of value doing what they're doing. And I think, we're kind of just saying, we're trying to get this on the hardware, right? And that's our main focus.
Right.
He sends us an email and we just try to figure out what S3 is and what not, and we send them.
So I think I've been involved in this a couple of times when something's broken in Linux Next. You bisect it, find it, and then you have to find what message ID it was and then post to that. Yeah, so that's the manual step there.
Okay, so one thing I heard, and from dev perspective, you guys said you guys got pulled off this project and you're kind of doing it in your free time. Is Linaro refocusing on this, or, because it kind of makes me hesitate to jump.
It's never been an official Linaro project ever. It's been a Skunkworks project that we're like, we want to do this, we need to get this thing done. And, we just kind of found like-minded people within Linaro to do it. And Linaro's been great. They gave us a little bit of time to work on it initially. They provided the builders. So they're definitely, have some stake in it, but it's not an official engineering project. It's been supported. Yeah, it's definitely been supported.
Is it going to continue to be supported? Okay. And did you guys ever extend, from last year, I attended the same CI talk, was there any extension to data mining, the data you were getting?
Like with Elasticsearch?
Yeah, we discussed that what was one of the plans, but then got derailed. The idea was to just throw everything back into Elasticsearch and provide a full text search on the website part, so you can just go ahead and search for a error message where it appears the first time, and fix like that. But yeah, no time.
Yeah, the service that IT was going to provide us never ended up happening because we were going to use their service rather than creating our own. So now it seems like we need to have our own server to do that mining. So that's kind of what blocked us there. But I still think that's a really good idea and it's something that we'd like to pursue. So what we've recently done, probably the newest thing, is that we've added MIPS support. So we're now building the MIPS def configs. We've upgraded the tool chains. We're able to kind of uniquely identify builds with different tool chains. So with this kernel CI v2 architecture that's all built on top of containers, we'd have containers with the different versions of GCC toolchain, potentially LLVM, which it makes it a lot easier for us to do those builds, because right now we have, deployment scripts that use Salt to configure the tool chains, and, they're statically configured on the builders, so it'll give us a little bit more flexibility into. We use, for the ARM side of things, we use Linaro's compiler. For x86, we use the distribution compiler, which we're running on Ubuntu. And then for MIPS, I believe it's
They sent us the.
I think it's
I don't
Code
remember which
Sorcery.
ones. If you go on the build
Yeah.
page, you'll see the version.
So that's
of
that's the
compiler.
first question we ask when somebody's like, can you add architecture X? It's like, where's your tool chain? What's the most common, supported tool chain? And that was the one that they provided to us, so.
What about RT?
Real time? So we do that on the LSK. So the LSK has a branch where they have the real-time patches based on whatever stable version they're on, and we test that, and then Anders from LNG actually runs like the real-time LTP tests on it.
But we don't boot test in RT.
We do, absolutely.
Off the LSK.
Yep.
So for testing, let's assume that I have one board that I would like to run certain tests for on daily basis, like ping something through a wireless LAN interface and something minimal. So what would be the best way to get that happening?
If you want to do it locally? You want to do it locally?
I could do it locally, but preferably on some server that is more reliable setup than my home connection.
So if you go look at the Lava CI project on GitHub, it's got templates for tests. So you need to find out where this board needs to live. What kind of board is it, and can you tell?
Well, I would pick something that's known to run, that should stay running.
Yeah, okay.
Yeah, so something could be QEMU or one of the boards working with things.
Yeah.
Basically just try to catch regressions early.
Yeah, so we have the ability to run the tests. We don't really have the reporting in place, but if we were hosted in one of the board farms, we could give you access to, basically have a cron job that would just send the job out every so often, or when the tree changes, you use a Git trigger to send the job there, and then it would pull you the results back locally. It just wouldn't get pushed to the kernel CI front end, because we're not ready to start displaying tests. Plus, we've had some members slightly concerned about having results posted in a public place, so we're treading very lightly there. We don't want to make anybody upset about the status of their board upstream.
So this is kernel. What do you guys do with bootloaders? How do you update them? How do you keep those in sync with the kernels?
That's a good question. So when something breaks, the first thing we probably phone up Tom and say, Tom, did something change in U-boot? Or we talk to the maintainers of the actual SOC and just say, hey, we've all this. It would be nice. The problem is, and we talked to Tom about this, starting to test U-boot in QEMU with the latest U-boot, latest kernel, and making sure everything works there. I think we need to get there before we have the confidence to, every time U-boot's released, we go through every board that's supported upstream and upgrade them. I mean, it's quite a lot of maintenance to do that.
Just as a follow-on to your question about U-boot, can you talk a little bit about the mechanics of how you're actually loading with the various targets, both bootloader and kernel? I'm assuming with kernel you're doing stuff like TFTP boot or whatnot, but more specifically with bootloaders.
Yeah. So we drive the bootloaders when we can over serial, right? And we do TFTP with U-boot, and that works awesome. UEFI will typically boot UEFI, will load Grub, and assuming UEFI provides the right drivers to Grub, we'll net boot off of Grub for the enterprise ARM servers. That's how we're doing that. Android devices that also boot upstream, we use Fastboot, which is less than ideal to do because we got 1 million USB connections now, plus the tooling around making these boot images are different from different SOCs, so we have to have a lot of hacky logic in there, and then the load addresses aren't as flexible. So what we'll do there is we'll typically create a boot image, put it on the device. We'd like to just load it into memory, but sometimes we actually have to flash it to flash and call a reset on the cell phone to get it to load the kernel. So there's a lot of different ways for the different Android cell phones that we support in kernel CI. But typically, the best way to work with the boards is TFTP, and that's what we prefer.
So you have a bootloader on there.
Yeah.
That loads the bootloader.
Now we have a bootloader that just statically configured. It's flashed into the ROM or wherever it's placed on the board. And then we power cycle the board. So it comes up, we grab the U-boot prompt, we break it, and then we configure a TFTP boot. Now the way Lava works, I can speak towards this, is it comes with a TFTP server and an NFS server. So what we do is when we're configuring the boot commands to boot, we point it back at the Lava server as the TFTP host, which then pulls the binary since Lava's already downloaded everything from the internet off the kernel CI storage, right? Gets sucked down to the board, loaded at whatever load address we tell it to, and then we jump to it.
So but you're using U-boot in Flash to load U-boot in RAM?
No. We're just leaving, we statically configure U-boot.
Okay.
And the idea is,
But if you're testing U-boot.
right, if we're testing U-boot, and what we've talked with Tom about is that we're gonna start with QEMU x86, right? We're gonna inject the latest U-boot, and then, yeah, exactly, yeah.
Yeah, so I just wanted to point out that none of what Tyler just said about how all that stuff works is not kernel CI specific. It's the jobs are just offloaded to Lava. The power of Lava is that it takes all this funky madness that people have got with their boards and just deals with it and boots the kernel you've told it to. So the fact that all these boards are so different is all the fun of Lava, right? It's the crazy
Fun of Lava, I guess.
Fun in massive double quotes.
We have looked inside Lava, we've looked long and hard about the ability of testing bootloaders. Most of the ARMv7 boards, particularly those that rely on an SD card, the hardware to do it is just not available because automation relies on the board always coming back up and not being bricked. You put a new version of U-boot on there, you're not sure if it's going to brick the device.
Yeah, you need
and
a
that
dual
device
bank
cannot then be automatically recovered. It doesn't have any BMI, it doesn't have any other way of getting into the device. You've got to have someone physically go there, take the SD card out, put a new one in.
You need something like a sock that's got a boot ROM.
Or JTAG, yeah.
So, we've looked at it. I can point to the blog entry. We've actually put down the criteria we need. There are no end of people who've come up with weekend hack solutions of this kind of solution. It sounds easy. I promise you, it is not easy to automate and do it properly with the kind of reliability that these guys need.
Well, and every platform's different. Now, there's some platforms, I have platforms that have 2 banks for U-boot, and you can switch it, and so you can wire up, some relay to drive the pins and select the bank, right? But that it's gonna work on a handful of boards, and we'd like it to work on all the boards if possible. Then we thought about chain loading U-boot, which is what I think you were getting at, and I don't like that because I've worked in software development doing bootloaders for a long time, and the stock bootloader may set up registers different than the bootloader that you just loaded, and everything works. And when some customer flashes it, the pins aren't set up right, and it works for me, exactly. So we really did not want to do that. But the good news is with Lava V2, I just submitted a patch for bare metal test support, so we're able to actually, so the demo that you saw on stage in the Monday keynote, we're doing this on embedded boards where you just squirt firmware in there, there's no POSIX shell, there's just output that gets parsed, right? So that's why we call it bare metal. But we could now extend that to do U-boot testing where we can get U-boot on like QEMU device and actually run through the menu and making sure that each piece of the menu works. So we have that ability in Lava V2, and that's why it's very enticing, and we want to start to move to using that rather than the V1 Lava. Go ahead.
A quick question about, except the boot testing, did you do some functional testing for the kernel, for the,
So we have K-self-test.
K-self-test? Only that's K-self?
Yeah, and then we have LTP and Hackbench, and we have some performance things that we can run, but we're not doing any test results in kernel CI, just boot testing.
Okay.
So what about JTAG support for loading? You guys have device direction within Lava, support JTAG. It's just so few devices.
Yeah, there's very few devices that actually need JTAG, but with Lava V2, you've got support inside that for LXC containers, and we've already worked out that basically you can put whatever software you need to drive whatever hardware you can make available to that container to actually do what the V1 JTAG support had to do. But even then, there's not many devices, and you can't roll that back and think, oh, that's going to be able to allow us to rescue U-boot either, because that support is very, very erratic, and very specific to individual boards, if it's available on the board at all, because you may well find that the JTAG is only on the prototype boards and isn't on the boards you just buy as commercial units anymore.
Anything else? Is kernel CI helpful to people? I mean, it sounds like there's some people that are using it daily, and that's good to hear. It's really good to hear, actually, because we don't know. So, and feel free to shout at us, too, if like there's something that you're just like, this is complete garbage, we can't use this.
I start my mornings looking at it.
That's really, that's good. Yeah.
But I think my point of view on more, I guess more on the management side of things, I see kernel CI as being something that's got open source consumers of it, but not contributors, right? And so what I would really like to see is to see people who want a feature like Elasticsearch work with Milo, figure out how to get it in there, and then start proposing those patches and really help us make this that project that's got contributions coming in from more people than these two guys.
Yeah, my idea of contribution of community for this one was not never like from a website development point of view, but most from a kernel side point of view. So just like fixing bugs, look at the website, reports, those kind of things. There's a little bit of activity on other people that have Lava labs that are integrated with kernel CI, so they fix the issues there. They just like bring up new boards. So there's activity there, but I never expected activity on that side of development point. So.
But cool.
Yeah, well, it's welcome.
So a couple of the features badly needed would be automated git bisect and boot instead of just producing the script. That would save huge amount of time if that could be automated.
We have it automated. It's just not to the point where when we get a regression,
Okay.
it's automatically kicked off. That's something that we have to go and
Yeah.
put parameters into. But that's a great idea.
We have a way of tracking regressions inside kernel CI.
Okay.
We never get to the point where it's available on the UI as well. That's one of the
Yeah.
is working, but
That-
it's going to happen. I'm not sure if it's on the email already, but it's going to be there first. At least tells you.
Okay. Yeah. That would save probably like at least half a day of time for me per week between RC2 and RC7. There was some other feature, but I have to come back to that later on when I remember it.
So how is boot testing on Android phones different than boot testing it on, development boards which we have? I mean, I know that on dev boards we just boot to console and right now that, okay, we are done. How do you do that on phones? Do you?
Well, see, and this is where it gets really complicated. I won't point anybody out, but there's tools where you have to inject, little IDs inside of device tree blocks and then, rebuild the device tree because it's got an index device tree and put the image together. So, and that's just like one board that requires that. And other boards where they don't use the same boot image format as Android does, right? And so we have to have, not calling anybody out specifically, right?
It's a Sony experience.
So that's how in the sense that I have to go write code for Lava to deal with a certain phone, whereas if there's a U-boot board, we just don't have to write code anymore, we just write a configuration, right, because it's all standard. So that's my biggest problem is that there's no standards for this. Like the Nexus devices are probably the closest thing to a standard, but then every other manufacturer that makes a phone likes to do things, slightly different. And so that's just our pain point, really.
Okay. So my question was more from, let's say, boot success or failure point of view, right? When you boot the image, when you flash the boot image and you just boot it to console and say, okay, everything is fine?
We do run some user space commands. We use buildroot and we run like mount, df, right? Simple commands.
Right.
And you think that's like, oh, that's so trivial. Like, why do you guys even do it? We've got kernel panics from running user space commands. Just, like that's triggering some driver to oops.
Right.
So it's actually kind of interesting.
Right, so it is similar to what we do on development boards because we run the same commands, right?
Exactly, yeah.
Right.
Yeah, exactly. So same exact things on Android commands as we do on development boards. It's just the bootstrapping process is different.
Right.
So just going back still to automated functional testing, that's something that we also badly need. Just basic testing, make sure MMC works and we can ping something over wireless LAN, nothing complex. And using kernel CI.org over past, let's say, 1.5 years, what I managed to do for myself is I managed to move the testing for regressions and dealing with the regressions from happening after RC1 to actually happening before the merge window opens. So that's a great help because that removes the urgency for trying to deal with regressions when it's too late after the merge window. So I've actually managed to get to the point where I can now use Linux Next between RC2 and RC7 on daily basis for my development work. So it has saved me a lot of time. So and that has also, of course, fixed some of the bugs because I have to keep it working for myself. So I would urge other people also to start doing that, and it might take probably up to a year depending on the hardware platform to get to that point. But once you are there, then you don't really want to see any regressions because you know that you have to deal with them later on. And then also what's interesting, what has changed during that time is that initially the regressions usually were somewhere in the ARM SoC tree, but it seems like that's now gone, and the regressions I'm seeing are mostly in driver subsystems and Linux generic features. So, so some kind of statistics on where the regressions happen might be really interesting and how they are changing. But I think we've gotten the ARM SoC in general into pretty good shape, and kernel CI.org has really helped with that. But now we need to get the Linaro driver subsystem maintainers to make sure that they don't produce regressions, because that's like still almost weekly event between RC2 and RC7, unfortunately. Not necessarily Linaro, but a lot of them for ARM devices are Linaro maintained.
So I know we do the MMC subsystem, and I know Kevin actually has some boards, I believe they're LTI boards that are being moved through MMC root file systems with them, and eMMC, I believe there's some of that, but it's not across the board, and I definitely think we need more of that functional testing. And it would be great to have tests written by the subsystem maintainers that we could run, because I think that's kind of the next step.
Although we need it, it's kind of a chicken and egg until we actually start running tests.
Exactly. Well, we got to get more people to help out with good results, because we just were not scaling it right. Once we see that happening, I think then we can have that discussion.
So you mentioned, I think you said something about standards. I don't remember what you said, but okay. So I'm the one that gave you the Sony Xperia phone, and it's got the weirdo, funky. You have to inject something in the device tree in order to make it work, and also it can't boot. It can't do fast boot from RAM, which is another issue. But what would be helpful, I think, industry-wide, I've thought about this a little bit, is if there were some kind of best practices document or even a meta test that says, you know, it's like if your board or your bootloader meets this set of criteria, like it can TFTP boot and that type of thing, that is kind of like the gold standard for testability. Then you can kind of get that out there so that, like, when Sony engineers are doing weird stuff with their firmware, we can say, hey, you're not following this standard. So I think that would be useful. I don't know how to kickstart something like that.
We definitely have a list of things that we'd like to see. And, you know, personally, from a cell phone perspective, it would be great to have a debug connector that works across all the phones, the micro USB Type-C, whatever connector you've got on there. Where
Yes.
you can power cycle it, you know, externally. And the Sony board actually has that, right?
Right.
I was looking at that going, okay, this is what we
We actually proposed something to USB-C to put debug in the standard. So, but I don't know if it went anywhere is the problem. Yeah, so I'm not sure how to follow up on that. I would like to follow up with you guys to somehow at least document these, if not put out, you know, some.
We could write a page up in kernel CI that says, you know, if you want your board tested.
We can even use the wiki feature of GitHub so everybody can contribute back to that, just like a pull request away. So we can enable that. We never enable anything outside of GitHub because we don't really use it for that thing, but we can do that. So just like write something, send a pull request.
Okay.
We can discuss that.
Yeah, I guess it would start by comparing notes. So.
A lot of the manufacturers do have those sort of features in-house already.
Right.
And, you know, if we could make a standard, you know, if there was a micro USB connector that you could buy that exposed the serial and.
It's, yeah, well, what was, because a lot of the manufacturers have this in-house already, I'd question how tractable it is to achieve getting them all to standardize, because they'd have to read all their test jigs and production lines. And like, I know some of the manufacturers didn't, well, they're moving to fastboot because they'd have to redo all the flashing tools.
Well, but even something like saying, please don't leave a serial console capability on your board. I mean,
90% of the production cell phones I've worked on do.
I think that for me, from my point of view, it's getting it into fast boot mode. So like on the Sony device, right, where you can't load into RAM, you can't erase the boot partition and then just have it stop in fast boot mode. That's typically what we do. But when you have to flash something, if the board oopses and resets itself, it's just going to continually just get stuck in a kernel oops. But you know, you have a setup there where you can actually get it into fast boot mode. So that works okay. But it would be great to see that standardized somehow that everybody can use across the industry. Go ahead.
Yeah, I was just going to add to that it may be hard with a lot of devices, but at least setting a bar out there
exactly
for people to attain.
Yep.
Yeah.
And give credit to the ones that are doing it right, saying these phones are doing it right.
Yeah, like I don't do cell phones, but I do some embedded systems that are not really commercial, but industrial. And putting a relay on a board and having it off of an FTDI GPIO expander, right? Or whatever that's off USB with some UARTs and JTAG, that's easy for me to go do. Having the bar set makes it easier for me to go do that.
Yeah. Yeah, and yeah. Yeah, I think maybe part of it is getting people to publish or to give access to what they already have. So I know shipping cell phones, people go, oh, you can't do this on. I know you physically can because I've worked on them. You just need the right test thing to plug in the port from the manufacturer. Well, they don't certainly won't admit it, but they won't give out that hardware.
Okay, really good discussion, guys. I'm glad everybody was so involved, but I think we are a few minutes over. So thank you for coming, and we'll continue to work on this and take your feedback. Thank you.
Thanks.